Alcohols are important in organic synthesis, both because the hydroxyl group occurs widely itself in natural compounds and synthetic compounds that are used commercially and medicinally, but also because alcohols are key intermediates in the synthesis of a wide variety of functional groups. Talking about the latter, the use of alcohols as intermediates, what we're thinking about then is some precursor, and there are several options, is used to make an alcohol of some type, and then that alcohol is used in one of a variety of reactions to make products. Of those, one of the types of reaction is substitution. In fact, nucleophilic substitution. Where the overall reaction and conversion of an alcohol to a compound where a nucleophile has replaced the OH group. Now at this point, you should be saying, but wait a minute. We've learned that hydroxyl groups are very poor leaving groups. That's not going to happen, and you are absolutely right. The hydroxyl group must be converted to a much better leaving group, and then in a subsequent step, the nucleophile replaces the better leaving group. So the concept is alcohol to compound with better leaving group, reaction with nucleophile, probably negatively charged, to form product. And we know that for nucleophilic substitution, the Sn1 mechanism is possible. The Sn2 mechanism is possible. For this one, we know that typical of tertiary alcohols, we know that racemization results when we have stereochemistry at that center. For the Sn2 reaction, we know that primary and secondary compounds typically undergo reactions by Sn2. The secondary, perhaps also some Sn1 reaction. We know, and this is very important, that inversion of stereochemistry may result. So what are the strategies for turning an alcohol into something with a better leaving group? There are 3 strategies. One is to make our OTS. We've already talked about this. The tosylate is an extremely good leaving group. And this works for Sn2 chemistry. And there's a wide variety of nucleophiles. A second strategy is to protonate that alcohol and make this a very good leaving group. Actually, this will lead to Sn1 or Sn2 chemistry. And the specific reagents are HCl and zinc chloride, to make chlorides, and HBr to make bromides. And which mechanism operates depends on whether we're talking about tertiary alcohols or primary and secondary alcohols. And the third strategy create an intermediate with a very good leaving group, having reacted with the reagent itself. So the alcohol has turned into this guy. We're going to make chlorides, and this is Sn2 chemistry only, or turned into a phosphorus equivalent. And this is Sn2 chemistry. So if you have a tertiary alcohol and you want to convert it using nucleophilic substitution, you'll be looking at the strategy number 2. If you have a secondary or primary alcohol and you'd like to use nucleophilic substitution, you can be using strategies number 1, number 2, or number 3. There are far more options. So, in summary, these reagents convert alcohols to intermediates that are far more reactive toward nucleophilic substitution because they have better leaving groups. And then in a nucleophilic Sn1 or Sn2 reaction, that leaving group is replaced by a nucleophile to make a variety of products depending on the nucleophile.